So to study what happens with ellipses, the best place to begin with, the best place to work around is usually the origin. That's how we'll see for all of our conic sections here, that we want to start with the origin and work outwards from there. Where if we're working from the center, we have two forms, x squared over a squared plus y squared over b squared equals 1, where this is our arrangement in the case of a horizontal ellipse, one's shaped a bit like a football, or maybe some other shapes if you have some other shapes in mind. And then we have the more vertical arrangement where we have x squared over b squared plus y squared over a squared equals 1. So it's got a bit more of an upward egg shape, if you want to think of it that way, where in particular, when we're talking about these things, we're talking about these values, these positions, we have a and b as positive values, where a squared is always bigger than b squared, as a squared gets attached to the major axis and b squared is attached to the minor axis. That is, the major has length 2a, and the minor has length 2b. And we have our other value c that we get, which tells us about the location of our two foci. That is, we have the foci, as you can hopefully see on these graphs, at a location c units away from the center, where the amount c depends on a and b. That is, c squared equals a squared minus b squared. And we have that they're upwards for a vertical ellipse, and left and right for a horizontal ellipse. And to see this, we'll get a quick example. So for this example, we want to graph and locate the foci of the equation 16x squared plus 9y squared equals 144. So for this, we want to start by getting it into a more standard form like so. So we have our, let me get this actually down here more, 16x squared plus 9y squared equals 144. And hey, it's very convenient that I set it up this way, because what we're going to do is divide out a 16 to get rid of that constant on that part, divide out a 9 to get rid of a constant on that part. And what we'll end up with is x squared over 9 plus y squared over 16 is equal to 1. And as a result, we can think of what's going on here in terms of that vertical arrangement, or you should be careful to notice that these are just switched a little bit around from that horizontal. So just pay close attention to which one of these is bigger, and that tells you what we're working with, where in particular we have x squared over 3 squared. So b is equal to 3, and y squared over 4 squared. So a will be equal to 4, and as a result, we are going to have that c squared is equal to 16 minus 9, or 7. So c is equal to the square root of 7. Technically speaking, it's a little bit more exacting than that. We have the positive or negative square root. To be careful there, because our foci in this case are 2 points, one above, one below, where from this we can then talk about what our graph will look like, because we're going to have a major axis that is vertical and has length 2 times 4, or 8, a minor axis that is horizontal and has length 6, and then our foci just on the inside up there, getting a graph like so, where for this graph we can see all of those properties as described. And just to be clear about what we have, because c is equal to plus or minus root 7 and we have the major axis along y. That means our foci will be at the points 0, negative root 7, and 0, positive root 7. As the position of the foci is always in terms of distance from the center, given described along the major axis in terms of c. We'll see more generally later on that it's not quite so clean as this, but it still follows that same type of pattern. And next, we're going to get one more example here where we're going to talk about this stuff in terms of kind of going the other direction. That is, being able to take some of this sort of information about positions for foci and vertices and turn it into the equation of an ellipse.